first we're going to go through the formulas you need to know for the ACT. Some of these are duh, like you knew that probably. Others are ones you might not have thought about. You need to know the area of a square formula, and I know that that's silly for me to say, but you also need to know its side squared, not just length times width. Sometimes you will need to know that because they'll give you the area, and you'll have to square root it to find the side. And so that comes up sometimes. Rectangle is base times height. Parallelogram is base times height. This last ACT you took, weren't there two of those? So you need to know the area of a parallelogram. Triangle. Trapezoid doesn't come up real often, but I do want to show you how to memorize that pretty easily. A trapezoid has two different bases. And so the formula for the area of a trapezoid is you average those two bases together and then multiply by the height. You see, average the two bases. So it's really base times height, but there's two different bases. That's where the 1/2 b1 plus b2 comes from. It's really just averaging the bases and multiplying by the height. Anyway, if you need to memorize that. All the angles in a triangle add to be 180. You need to know that. You need to know the Pythagorean Theorem. How many Pythagorean Theorem problems were there on this one? 4? The one you just took, 4 Pythagorean Theorem problems. So you need to know that. There was one of these on the test you took. Remember that the double the perimeter problem, that weird double the perimeter problem? Anyway, you had to recognize that it was a 45, 45, 90 triangle, and so the hypotenuse was x radical 2, so you could find the sides were x. I think it was 4 on that problem, or something like that. So you need to know both of those. And you need to know this picture, but what you really need to know is SOHCAHTOA. You need to know SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, that's the first page. Second page, and I am going to give you some examples on this second page. So the random purple writing at the top of my page is some examples. The first one, you definitely need to know the circumference and area of a circle formulas. Those come up all the time. But then sometimes on the ACT, they'll ask you to find the area or the length around part of a circle. Not the whole thing, just part of it. Do y'all know what kind of problems I'm talking about? Have y'all seen that? Yeah, area of a sector or the arc length. Well, to do those, these are the formulas, but at first glance, those look kind of scary, so I want to show you what those really are. Isn't 2 pi r just circumference? And then if you take 2 pi r and multiply it by a portion of the circle, you get the arc length. So what I mean by that, say I want the length around 30 degrees of a circle. If the radius is 1, I'm going to find the length around the whole circle, which is 2 pi times 1, and then I'm going to multiply it by 33/60ths. Why 33/60ths? I only want 30 out of the 360 degrees. So I'm doing a proportion, sort of. So I'm getting just the part of that circumference. Does that make sense? So you multiply the circumference by 30 out of 360. That's how you find the length of an arc. To do the area of a sector of a circle, you do the angle out of 360 times the area formula, which is pi r squared. So if you know the area and circumference formulas, these two are just an extension of those two formulas. You saw this formula on the test, the ACT practice test that you took twice, right? It is the equation of a circle. The center is at HK and the radius is R. I all but would guarantee that will be on your next ACT. It's always on there. You need to know the distance formula and the midpoint formula. If you forget those, listen, I'll show you how to remember them. If you make 100 on a test and you make a 90 on a test, what's the middle? How do you get that mathematically? You add it up and divide by 2? That's the middle, right? So the midpoint, you add the x's up and divide by 2, it gives you the middle x. You add the y's up and divide by 2, that gives you the middle y. That's the formula. That makes sense? The distance formula. If you get on the ACT and you forget the distance formula, draw a picture. Okay, so I have a picture of a triangle up here. I've drawn, so I have a point here and a point here, and I want the distance between them. Draw a quick right triangle, find the x distance and find the y distance, and do the Pythagorean theorem. Did you know that the distance formula is just the Pythagorean theorem? Did you know that? Yes. Sure.
On like the circles and the two circles at the top over there, they're just the 121.
Yep.
Are they going to split the circles with an
They
angle?
will give you the angle if they ask you that question.
Okay.
Yes. If they don't give you the angle, they might say half the circle, and then you just multiply by half instead of that. But most of the time they'll give you an angle. This distance would be x2 minus x1. This distance would be y2 minus y1. That's why the distance formula looks like this. It's the Pythagorean theorem. So if you ever forget it, just do the Pythagorean theorem. Does that make sense to everyone? And see how that works? It's pretty cool to know. You might remember that way. Slope is rise over run. You need to know that. You need to know y equals mx plus b. And I would say it would be really good if you also knew this one that's not on the sheet. That is the equation of a line in point slope form. That way you can find the equation of a line through a point with a certain slope. We'll talk more about that equation in chapter 1. We'll do some more stuff with linear equations in chapter 1 in this book. The rest of those formulas you don't need to know on this page. If they want you to find something with a sphere, they'll give you the formula. Now they may ask you about it, but they'll give you the formula. So those are not formulas you need to memorize. Any questions so far? Cold. Okay. Here. Are we ready for the next page? Who asked me to wait? Was it Tatum? Okay. Let me know when you're ready. Okay. All right, this next page, of course, it would be great to read through. It has some good information on it. This is actually from an ACT prep book. This printout is from an ACT prep book. And I think they're all good things to know. I do think you probably know this left-hand column if you thought about it, if you look at it. One thing I would recommend is that you go over the properties of exponents, this little section here. That is how you, these properties is how you know how to do those problems over there with the A, B, and C. You remember the one we did on the board the other day? The negative exponent going to the top and all of that information. That is found in here. This will kind of talk to you about that information. The only problem is there's one written wrong. I noticed that. This should be a minus b right here. That should be a minus b. X to the a divided by x to the b is x to the a minus b. You subtract exponents. And then if you have a negative exponent, that's the same thing as x to the a. So that would be a good addition to that little piece of information. Okay. Again, this page has a lot of great stuff on it, but nothing I would highlight. Part of why there's nothing I would highlight is all these formulas for circles you already highlighted on the last page. So they're great, but you just already highlighted them. Number 4 on the formulas for triangles. Those are the what are called the Pythagorean triples. If you will, someone randomly pull a problem from the test you just took that had a Pythagorean theorem on it. Anyone have one of those? Remember any of those?
10, 8, 6.
Okay, 10, 8, 6. Sorry, it's coming back. 10, 8, 6. Look at it. 6, 8, 10. If you had that memorized, you could skip doing the Pythagorean theorem and use that stuff. If time is an issue on the math part for you, these could speed you up because you could almost never have to do a Pythagorean theorem problem because almost all, now I'll show you one today that you actually have to do the Pythagorean theorem. But almost all of them fit either the 3, 4, 5, the 6, 8, 10, the 9, 12, 15, 5, 12, 13. I would even say those are the most common, and these other two do show up occasionally. So if you knew them, you would never have to do a Pythagorean theorem. You could just label the other one. Make sure if you use those, the hypotenuse is always the biggest one. So those are good to know. This doesn't show up on every ACT, but it shows up on some of them. The number of degrees in a polygon. Now, what in the world that means, if you have like an octagon, the total number of degrees in an octagon is 8 minus 2 times 180, or 6 times 180, which is 1,080. So all the interior angles in an octagon add up to be 1,080. If you wanted just one of the angles, if it's a regular octagon, all the angles are the same, you can divide that by 8 and get those. So that's a formula that every now and again it shows up. You need to know that vertical angles are congruent. Complementary angles add up to be 90 degrees. How many of you get complementary and supplementary mixed up sometimes? A couple of you? Here's how you remember it. It's corny, I'm sorry, you'll forgive me later. Complementing is the right thing to do. Get it? Okay, so complementary angles are right angles, they make 90 degree angles. Supplements make you big, right? So supplementary angles are the 180. I don't know, if you can't remember them, use that, it'll help. If you already knew, forget you heard those corny jokes. Okay. So those are the big ones. That last one's nice to know, but not as important as those two. Another formula that occasionally comes up, even rarer than any of those, but I've seen it once or twice. All of the exterior angles in a polygon, so if you looked at this octagon and you added up all the exterior angles, those all add to be 360 in every polygon, not just an octagon. In every polygon, the exterior angles add to be 360. Think all the way around. All the way around the outside adds to be 360. So that's nice to know. You need to know the quadratic formula. Again, you need to know these formulas too, but we already highlighted them on the other page. So that's good to know. Quadratic formula. So that's formulas. Any questions about formulas? So general information about the ACT, and then I'm going to work some common problem types that show up a lot. There are 60 questions on the math part of the ACT. You have 60 minutes. It is common for people to say that means you have a minute per question. I would say that the timing's a little off on that. You actually have the first 30, which you probably learned that on this test, the first 30 don't take a whole minute per question. The last 30 take longer than a minute per question. So actually when you're kind of watching your time, on the first 30 you want to be faster than a minute per question. And then later you will slow down because they get harder. You probably felt that on this test. If time is an issue for you, that's something you'll need to watch. The first 30 need to go faster than a minute per question, and then we'll slow down. Don't substitute speed for accuracy though. I gave you that handout, what you need to make on the ACT to get certain things right. You don't have to get all 60 right to get a really good ACT score. So it's okay to miss a few here and there. But if you're getting to where you can't answer the last 20 questions, then you might need to speed up. So it depends. If you felt pretty good on the practice ACT on time, then don't worry about time and do what you've always done. If time was a big issue, then kind of watch the clock and try to be a little faster than a minute per question at the beginning. Skip things that you don't know how to do, and even skip things that you see is going to take you a really long time. Come back to them at the end maybe if you have time, But if you see a problem, you're like, I could work that, but it'd take me 5 minutes. Cut your losses, go get 5 other problems right, come back to it later. The questions range from pre-algebra all the way through trigonometry. Trigonometry is the high end on what's on the ACT. A lot of people who haven't had trig, which is you, freak out on the trig problems. You skip it. It doesn't matter. There are 4 of them. 2 of them you can get with SOHCAHTOA. So actually, 2 of them is all you can't get. If you only miss 2 questions on the ACT, you're making a 34 on the math part, right? So that's great news. That means that there are 58 other questions we can answer just fine. So don't freak out about the trig ones. Put an answer down, move on, don't worry about it. Don't spend too much time on any one question. Look at problems in a different way. And I want to show you an example of something like that. This is a problem on an old ACT. This is a rectangle, and it gave you a lot of information, gave you some points. I don't think they were originally drawn on there, but it did give you the grid. And it says, what are the coordinates?
Teachers and students, give your attention please. Between now and the end of the period, if you're wanting any tickets for the game tonight, you need to come purchase them, because this will be the last call for them.
Okay. They wanted the coordinates for the other vertex of the rectangle. If you try to work that algebraically, it would take forever, because you'd have to worry about parallel lines and perpendicular lines. If you were in a geometry class, you would make that a long problem, because you would ensure everything was parallel and perfect. This is an ACT. Your math teacher doesn't care what you do. Draw a rectangle and see which point's closest. You see what I mean by that? So think about it outside the box. This test is not for me. I don't need to see your work. I don't care what you do for work. If you do nothing for work, that's great. So just keep that in mind on the ACT. It's a little different than math class. Some of the questions, the easiest way to work them is to eye it. Otherwise, you'd spend way too much time on that. So just keep that in mind. Look at it a little outside the box. If you have never changed your calculator batteries, or you don't ever remember changing your calculator batteries, before you go to the ACT, change them. Okay? If you changed them last week, they're good. They will usually last a year or 2. But if you have a calculator and you've never changed the batteries, just for safekeeping, spend a couple bucks, buy some AAA batteries, switch batteries out so that your calculator doesn't die on you in the middle of the ACT. Just a mental note. Calculator programs. There are calculator programs for the ACT. Through the semester, I will teach you how to use some of those. If you haven't been taught how to use them, don't pick an ACT program up on the day of the test and try to use it. It'll slow you down, it'll lower your score. If you want to learn how to use ACT programs before I'm ready to teach you, come see me and I'll teach you so that you use them correctly and efficiently. Otherwise, they end up being a big time waster and slow you down. So if someone tonight says, you want an ACT program? Say no. It's too close to the test. If you want to get good at that for next ACT, we'll do that. But this test is too close and you don't have time to learn them right, so just be careful about that. When you don't know the answer, pick a letter in your head at the beginning of the test and stick with it on all of your answers that you don't know the answer to. Statistically speaking, if you stick with the same answer the whole time on the ones you don't know, especially at the end, statistically speaking, you'll get more right than if you bounce around on those. You want to know what I mean by that? So they do say not to pick C, because they say people used to always pick C, so ACT learned that. Who knows, ACT may go back to C. I don't know, just pick one and stick with it. Whatever spot you decide to pick, every ACT is different, so we're just guessing at that point, right? So it doesn't matter what you guess, but I would stick with whatever you decide to guess. Stick with it. Statistically, you'll have a better shot on that. Any questions so far? I'm going to go through and work some common problem types. If there is a common problem type that you know that I don't end up pulling out, let me know and I'll work one of those too. These are not the ones that you have on your ACT, and I did that on purpose because I'm giving you another look at some more problems. So I did pick up a different ACT to show you problems. The first one I want to look at is a percentage problem. There is usually a percent problem on every ACT, if not 2 or 3 of them. Sorry about that. There you go. Okay, so this one is a percent problem. The answers are out there. That's actually not my handwriting. This is, I don't know where I got this book. Somebody else's handwriting. So, a couple of them I may work a little differently than they do. But what I want to teach you how to do is read a percentage problem. Anytime you read the word of, you think multiplication. Anytime you read the word of, think multiplication. So 40% of a number. Do I know what the number is? No, I'm going to call it x. 40% of a number x is 8. So 40% of x is 8. Does everyone see how that equation is written out based on that, how I read that? Anytime you see is, that's equals. So 40% of a number equals 8. And when you do 40%, you write it as 0.4. Does everyone know what the word percent means? Per 100. So 40 out of 100. That's why it's 0.4. So 40% is 0.4. That makes sense? So 0.4, 8 divided by 0.4 is 20. But it says, what is 15% of the given number? Well, that's the number. What's 15% of that? I'm going to multiply that by 15%. And it evidently gives me 3. Does everyone see how that works? So you will see a percent problem on the ACT. Again, this is being recorded, so if you miss something and decide you want to go back and watch it, this will be on Edline tonight. So I'll post it just like I'd post a normal video that we do. Okay, I want to do a midpoint problem. Midpoints became such a common thing on the ACT. The ACT kind of upped the game a few years ago, and they made midpoint problems a little more challenging. So I'm going to show you how that works. Now, remember, think outside the box. If you get on this and you've completely forgotten the formula, draw a picture. Some of the answers on there make no sense. Do you know what I mean by that? Some of the answers on there are way off of the middle. You could probably get the midpoint by guessing appropriately if you drew a picture. I'm going to show you the way to work this out, but keep stuff like that in mind. Think outside the box. If you get stuck, draw a picture, see what you can come up with a picture. ACT generally or a lot of times make things where you can just look at the picture and find it. To actually work one of these midpoint problems, the thing that's weird about this is they give you the coordinates of the midpoint. So they say the midpoint is 5, 4. So it's like they're giving us the answer. One of the points is 7, 3. What's the other point? Seems like this is the way they're asking midpoint right now. So anyway, how you do that? The point is 7, 3. I don't know the other point. But I know to do a midpoint, I would average the x's, right? And I would average the y's. This equals 5. The average of the x's evidently equals 5 because that's the midpoint. Now, if this were a more straightforward midpoint problem, you'd just put the other number here, average them, you'd be done with it. I'm going to work backwards and solve for that x. I get 7 plus x equals 10. So x equals 3. Another hint, shortcut on the ACT. On a multi-part problem, look once you get here. There's only one answer with a 3 for the x, isn't there? You see that? It has to be that one. Don't waste your time finding the y. That makes sense. We already found the answer. Skip it, put the answer down, and move on. You don't have to answer the question completely. As soon as you know the answer, you stop and go. All right. I'm going to talk a little bit about a proportion problem. There was one on your test that was a recipe. This one's completely different type of problem, but still a proportion. This one says, I'm going to look at number 15. If the information in the table above were converted into a circle graph, which is a pie chart, then the central angle of the sector for Gomez would be how many degrees? Well, you need to see the table. Time out. Go up really quick. Gomez has 40 votes out of 200. It told me there were a total of 200 at the top. So Gomez has 40 votes out of 200. I want to know how much of a circle he should get. Well, how many degrees are in the whole circle? How many degrees all the way around the circle? 360, right? A skateboarder does a 360 all the way around the circle, right? So I want to know how many out of 360. So to set this up, you'd use a proportion. Gomez had 40 out of 200. How many out of 360? Does everyone see how that works? And you cross multiply and solve for x. The problem y'all had on your test was you have 24 cookies. 24 cookies. And it takes 2 cups of flour. How many cups of flour would it take for 72 cookies? 68 cookies. Okay, that's how you'd solve that. Okay. Does that make sense? So that's how proportion problems work. There will be one of those on your ACT. There's always a proportion problem. Parallel perpendicular lines show up a lot on ACTs. Yours was a perpendicular line, wasn't it, on your ACT? This one's a parallel line. Parallel lines have the same slope. So 2 lines that are parallel have the same slope. Perpendicular have opposite reciprocal slopes. What would that mean? So if we had perpendicular, the sign would change and it would flip. You remember me telling you ACTs start to all look the same? Even though these are completely different questions, do you see how they're equivalent to some of the ones that was on yours? Look at number 18. It's even a sad attempt to change a problem. Janelle cuts a board instead of a ribbon. 30 feet long into 2 feet. Is this not the same exact question you had? If you take enough practice tests, you can start to pick these out. This is really a different ACT test than the one you had. And what was it, Susie cutting a ribbon instead of Janelle cutting a board?
It was like still the same numbers.
Same numbers and everything. Oh my goodness, right? This is the algebraic way to work this one out. I would like to show you the thinking it through way to work out. She's cutting a board or a candy bar or a ribbon or whatever we decide to cut up that day into 2 pieces. But it's in 3 parts to 2 parts. So instead of thinking 2 pieces, you need to think 5 pieces. And she cut 3 parts and 2 parts, which is 5. Does everyone see that? If I cut 30 into 5 pieces, how long would each piece be? 30 divided by 5 pieces. Each one would be 6. So how long would 2 of them be? And how long would 3 of them be? So 12 and 18 would be the size of the 2 pieces. Does that make sense? So that's the think it through way. That's the algebraic way. The shorter piece would be 12. I don't remember. Yours might have actually been the longer piece. Yeah. So your question was a little different. It was the longer piece. So yours was 18. The answer to yours was 18 instead of 12. Number 19. The big thing you need to know on 19 is those words. Integer, rational number, all that fun stuff. So I've got a little diagram for you. Graphic organizer. Yeah, math people can do that too. Maybe. So, on a set of numbers, the very first set of numbers you learn is natural numbers or whole numbers. Like that's the kind of numbers my 3-year-old counts with, right? 1, 2, 3, 4, right? All those are whole numbers or natural numbers. Integers include all of the whole numbers and natural numbers, but they also include negatives. So 1 is an integer. But -1 is also an integer. You see why I did a graphic organizer? The whole numbers are part of the integers. That's why it's inside the box. I was being creative. There you go. So rational numbers, rational numbers. You see that I have the underlined on rational the word ratio. What is a ratio? A fraction. So rational numbers are numbers that can be written as fractions. Of course, integers can be written as fractions, right? 3 over 1, 5 over 1, -6 over 1. So all integers are rational. But then so are things like 0.5, because that's a half. 0.3 repeating, because that's a third. Anything that can be written as a fraction. Which brings me to what is not rational. Weird numbers like the square root of 2. Those don't turn out nice. That's not rational. E, pi, square roots of anything that don't actually give you an integer, those are all irrational numbers. The whole set of numbers in this whole picture are called real numbers. So real numbers covers all of them. Non-real numbers are the i's. So they're kind of on their own. They're on their own program. They're weird. But this is all the real numbers. These are the ones that ACT asks you about most of the time. This one you probably could have figured out without knowing what integer was because the answers were only integers, but I'll show you ones later that you would have to know. I would type the square root of 58 in my calculator. It's 7 point something. So the smallest integer greater than it would be 8. Okay, there's one just like this on your test. You will need to know how to distribute an exponent. You can only distribute an exponent if there's not a plus in between. If there's a plus in between, you're going to have to FOIL. You're going to have to write it. You remember the one on your test that was like 3x plus y squared? You have to do 3x plus y twice and square it. This one, you can just distribute the exponent, so you do 3 cubed and x cubed, and that you get 27x to the 9th. If you get stuck on one of those, write out what it means. 3x cubed means 3x cubed 3 different times multiplied together. It might help you if you forget a rule, how to do that. Number 38, let's do a SOHCAHTOA problem. I want the sine of angle M, is what it tells me I want. Sine of angle M. Okay, the sine of M, would you agree it's this side over the hypotenuse? Right? I don't know that side. 10 and 12 are not any of my Pythagorean triples. So I actually have to do the Pythagorean Theorem. So if you needed to see a Pythagorean Theorem worked out, you always make the hypotenuse the C in the Pythagorean Theorem. So you get 144 equals 100 plus b squared. Subtract the 100, I get 44 equals b squared. So b is the square root of 44. So sine, I'm going to go back to my SOHCAHTOA. Sine is opposite over hypotenuse. So across from the M, the opposite side from angle M is the square root of 44, and the hypotenuse is 12. Does everyone see how I know that? So the answer is square root of 44 over 12. Again, though, I want to teach you a little bit about ACT. Look at the answers. I know the answer is not 10 over 12, because isn't that the cosine, the adjacent over hypotenuse? Right? None of the others have 12 on the bottom. So wouldn't the answer have to be K, even if you couldn't find the square root of 44 for some reason? Because it's the only one that makes sense with opposite over hypotenuse. So keep stuff like that in mind. Even if you get stuck, reasonably think about the answers and see if there's any shortcuts you can take. Let's look at number 45. You remember me telling you about those words? What does rational mean? To be written as a fraction. Well, I know the square root of 2 can't. I imagine the square root of pi can't. These all seem irrational. But what's the square root of 64? And what's the square root of 49? So that's rational because it's just 8/7. Okay, does that make sense? That's an impossible problem if you don't know what the word rational means. So, little interesting one. The last one I want to do before I let y'all just ask me questions is this one, a lot like midpoint. This has shown up a lot, and that is, I think it's the last one. I might have another one or two circled. This one is average, except it doesn't ask you to average numbers because that's easy, right? We can all average numbers up. Instead of asking you to average numbers, it says, Tom has taken 5 of the 8 equally weighted tests in his U.S. history class this semester. He has an average score of 78. How many points does he need to earn on the 6th test to bring his average score to an 80? So how are you going to do that? Well, I have 6 tests, and they threw in a distractor of the 8. They tried to trick you with the 8 there. But I really only have 6 tests that I'm thinking about. And I'm going to assume I made a 78 on all 5 of the ones I took. I don't really know what I made, but I know it averaged to be a 78, so it might as well have been a 78 on each one. I don't know what I made on the 6th one. That's what I want to know. That needs to equal 80. That needs to average to be 80. So I'm going to set up that equation and solve for x. Add all those 78s up. It's 390. Multiply by the 6. I get 390 plus x equals 480. And then subtract the 390 over, and you get 90. Now, think about it also, if you've made a 78 on 4 tests, is a 79 going to bring you up to an 80? No. Is an 80 going to bring you up to an 80? So you can eliminate some, you may not be able to actually get the 90, but you could at least probably eliminate it down to the A and B. So you give yourself a 50-50 shot instead of just a random guess. Before I do any more, do y'all have any more questions, or do y'all have any questions for me? Any common question types that show up that you want to know about? Do we need to see a circle one or anything like that? Was this helpful? Yes? Okay. Good luck tomorrow. Your homework for tonight is to get ready for the ACT. Again, if you have time this weekend, go ahead and work on that Chapter 1 toolbox. If not, you can do it on Monday night. But I will tell you, it is a long assignment for Monday night. So if you want to break that up, do a little over the weekend. Okay? And good luck tonight.